In our nugget here on VLAN access control lists, otherwise known as VLAN access maps, we saw how we can control traffic within a VLAN. We're going to look at another powerful methodology for doing this in this particular nugget. It's the PVLAN or Private VLAN feature. With the Private VLAN functionality, we create a Private VLAN domain, and this domain consists of a primary VLAN, and then inside it we create secondary or sub VLANs. These sub VLANs can be of two different types, as you see here. There is what's called an isolated VLAN that can only communicate with the promiscuous port. The promiscuous port is that port that would allow such a VLAN member to communicate with the outside world. Notice it cannot communicate with any other device within the primary VLAN. Then we can create, if we like, a secondary type called a community VLAN. Sure enough, the members of that community VLAN can communicate with each other, and of course they can communicate with the promiscuous port to get to the outside world, but they can't communicate with anyone else. So it's a great way in which to segment with inside of our VLAN. Keep in mind, all of the devices are addressed in the same subnet within this structure, but it's like there's inter-subnet rules in place. Yeah, but there is only that one subnet. So this is an address conservation feature as well. So here we have the topology that I've built for this particular practice that we want to do with private VLANs. Here we are on R3 and everyone is in VLAN 100. Let me test the connectivity by pinging R1 from R3, and that works just great. Let's ping R5 from R3. That works terrific. And then I created a VLAN interface, a switched virtual interface on switch 3 at 10.10.10.100, and we can see that connectivity works great. We'll use the SVI on switch 3 as the promiscuous port. Let's go ahead and put R5 and R1 in a community VLAN with each other, and we'll put R3 in an isolated VLAN, and then we'll see the result of this configuration through testing. Now, the very first configuration we want to ensure is that switch 1 and switch 3, if we're running VTP version 2, we want to make sure they're in transparent mode, because private VLAN functionality is extended VLAN functionality and we want them in transparent. Please note, if you are running VTP version 3 in your environment, it can actually propagate automatically the private VLAN information, so you don't have to configure it on each and every device. Pretty cool. So we'll go over to switch 3 and we'll say VTP mode transparent. And we'll do this same thing on switch 1. So that's VTP mode transparent there as well. Excellent. Now that they are set to transparent operation, and I do believe show VTP status that we're running VTP version 2. Let's see, VTP version 2, and then VTP v2 mode is disabled. So we're actually running VTP version 1 here in this particular scenario, and that's great. No problem. As long as we're transparent, we'll be good. Our next step is to go ahead and define the private VLAN structure. So easy to do. Watch this. On switch 1, we'll say VLAN 100. We know we have VLAN 100 in our scenario right now, and I'm going to go ahead and make that the primary private VLAN structure. So we say private VLAN primary. That's it. I'll go ahead and exit from that VLAN and enter VLAN 200. By the way, that did not exist in our scenario. So we just created VLAN 200, and I'm going to make it a private VLAN of the type isolated. We're going to exit. I'll say VLAN 300, and we're going to say private VLAN community. There we go. So we begin simply by defining the components of our private VLAN. And the last step of that is to go ahead and associate these two sub VLANs with the primary VLAN. So we go back into the primary VLAN and we say private VLAN association, and use your context sensitive help here, and we can go ahead and add the VLANs 200 and 300 to the primary VLAN. So now we have completely defined the private VLAN infrastructure here. We've got the primary VLAN of 100, our isolated VLAN of 200, our community VLAN of 300, and they are properly associated with the primary VLAN of 100. So we said in our scenario here, we wanted R5 and R1 to be part of a community VLAN. And that's VLAN 300 in our scenario. So watch how easy this is. We go under those interfaces to configure that. I'll say interface range FA0/1 and FA0/5. We change the mode of the switch port. We say switch port mode private VLAN, and these are host ports. We then have to do our host association, making these ports part of that sub VLAN 300 that's also part of VLAN 100. This is done with the switch port private VLAN command, and we say host association, it's the primary followed by the secondary. In this case, it's VLAN 300 for these two ports to make them part of a nice community. So there we go. We enacted the appropriate configuration on switch 1. It's time for us to slide over to switch 3. Switch 3, we need to configure the promiscuous port on the VLAN interface, and we also need to configure the isolated port on Fast Ethernet 0/3. So here we are on switch 3. And we need to begin by defining our private VLAN structure. We have VLAN 100. This is a private VLAN that is primary. We have VLAN 200. This is a private VLAN that is isolated. And then we have VLAN 300. And this is the private VLAN type that is a community sub VLAN. Excellent. We can't forget about our association, though, for VLAN 100. So I go back into VLAN 100, and I say private VLAN association. Let's add to this our 200 and 300 sub VLANs. So there we go. We have defined the private VLAN structure. And we know that we have an isolated port that we want to create for the R3 device. So we go into interface Fast Ethernet 0/3. We say switch port mode private VLAN, and we're dealing with a host port. What's the other option here, by the way? Well, this is how we could create our promiscuous port. We're doing a host port here. And what is our association? Well, let's do it. Switch port private VLAN, and the host association here is 100, 200. That's because this one is an isolated port, and we're doing the VLAN 200 for that isolated behavior. Obviously, we need to remember how we numbered our sub VLANs and their particular characteristic, whether they're isolated or community. So now what's left for us to configure is the promiscuous port on switch 3. Now let's just say it was a physical port leading out to a router. And let's just say it was Fast Ethernet 0/4. Here's how you would configure that. You would say switch port mode promiscuous, or excuse me, private VLAN promiscuous. We saw this command a moment ago. So you would make it a promiscuous port, and then you would go in and you would say switch port private VLAN, and you would add your mappings. You would map the primary with the sub VLANs. Okay, no problem. But we don't have that in our scenario. We don't have a physical interface to be promiscuous. Instead, we have a VLAN interface, an SVI. So it's even easier. We go into that SVI interface, and all we need to do is say private VLAN mapping and map those sub VLANs to that SVI. And now we have a promiscuous SVI. That sounds like a bad thing, but it's what we need in this scenario. So let's go over to R3 and do our testing. Now we got to think, what do we expect to occur if we've done things right? Well, I expect that the R3 device can no longer ping R5. That's what I expect, because R5 is in a community sub VLAN and R3 is in an isolated sub VLAN. Nope, doesn't work. Great. How about R1, the other community VLAN member? I don't think this is going to work. How about the promiscuous port, though? We better be able to communicate with that port, the SVI on switch 3, and we can. So R3 is behaving just as it should. Let's go over to R5 quickly. R5 should be able to communicate with R1, its other community sub VLAN member, and it should be able to communicate with the promiscuous port. Let's try it. So we'll do ping of 10.10.10.1. We can communicate with our other community member. We can't communicate, as we know, with the R3 device. And our last test is to ensure that R5 can communicate with the promiscuous port in our environment. So let's try that. We're going to ping the .100 address, and we can communicate with the promiscuous port just fine. So a bit of an involved configuration, but not difficult, especially if you break it down step by step. Think about it. Step 1 is to make sure we're transparent, or VTP version 3. Step 2, we want to go ahead and ensure that we define the structure properly. What are the sub VLANs? What are their type? What's the primary VLAN? And associate those entities together. Step 3, go for your private VLAN host port configurations. Sure, simple. You've got some isolated ports, you've got some community ports. Hey, over there, you got a community port over there. Hey, suddenly I'm a bad actor in The Sopranos. Step 4, we are going to go ahead and configure the promiscuous port. A different configuration slightly if we're on a physical interface or an SVI, but simple nonetheless. So this nugget examined private VLANs and their configuration and their testing. And if you wanted to quickly just see the setup of your private VLAN infrastructure, let me wrap up by showing you just how easy it would be to verify that. Watch this. If we go over to switch 3, you can do a show VLAN, but you can say that you want to see the private VLAN infrastructure that is set up on that particular device. So yes, we do have verification commands that can help us ensure that our configuration is correct. And as you saw in this particular nugget, there's just nothing like the power of a ping when testing your configuration. I sure hope you found this nugget informative, and I'd like to thank you for viewing.